All right, this video covers the next two worksheet things, the how to start up the motors, the outputs, and then also how to program the inputs. So first we're going to talk about this is remember the beginning template that I've got here. You've got all my different things are here, all my different sensors, all my different motors, and then down here, this is the task main. This is where for most of what we're doing, all programming occurs here. There's only a couple advanced things at the end that don't. These are what we call curly braces right here. These are the curly braces. Everything happens inside the curly braces under the task main. These are our programs right here. We've got our movement, starting motors. This is our flashlight and light, and our weight. This is what we're going to have for the first part. You put everything in here and you just drag and drop. It's really easy. So if I want to start a motor, I click on Start Motor. I drag it over to here. I like to leave at least one blank line. Don't put anything directly after the curly braces, but you have something like this. Now I want to start my motor. What are my motors called? I have a left motor and a right motor. So if I double click on this, the whole thing highlights and I can start typing left, and as I type it, it tells me some possibilities. If you always do this and then click on that way I know it's going to be spelled right. I know whether something's capitalized or not. And then I'm going to put in the speed. I'm going to say 65 because that's about half speed, which a lot of things say half speed. And you'll notice there's a semicolon here at the end. That tells me that's the end of that line. Now, you'll see this green up here. You'll notice how that turned red. These are commands. There's a lot of different color things going on here. If I hit this double line like that, it went from red to green. And now I can type on in here motor. Anything after this double slash is in green. That is a comment. I'm going to be telling you that I want you to comment your code. You tell what's going on here. So now if I just left it like this, I talked about this in class, nothing would happen. You would think the motor would just start and keep on going. No, because the program just runs right through this, whoosh, and then it's done. Nothing happened. The motor might have started for a millisecond. I need to tell it, no, before the program ends, let's wait with that on. So I grab a wait. Milliseconds, if you want to have less than a second, that would be thousandths of a second. So I would have 2,000 milliseconds if I want 2 seconds. Or if I just grab this one and bring it here, those are seconds. So I double click on that, it highlights, and I put 5. Okay? Okay, and then and you can use the tab or whatever to bring it over a ways, hit that double slash. And you might think, well, I don't need to explain all that, but this is wait for 5 seconds. Motor starts, wait for 5 seconds. Now, if I didn't do anything else, the motor would stop because the program would end. But I want to have a clean program that's not depending on that, so I bring a stop motor. Double click on this, and I start typing. At some point, it gets the one that I want, and I double click on that. Stop motor. Our motor stops. And you can also do these kinds of things up here. Task description would be, something like that. Pseudo code is where you're not writing it like this. Actually, this would be more of a pseudo code probably than a task description. I want to run a pump for 5 seconds and stop. Yeah, I want to run a pump for 5 seconds, and then that would be it. So this right here would be my program to start it for 5 seconds. And you're going to do the same thing for, this could be my flashlight. It could be my LED. Those are my main driven things. Those are my main outputs. Motors is the major output. So you're going to, most of that first one, the outputs, is doing this kind of thing. And if I want to turn my motor in the opposite direction, -65. That runs it in the opposite direction. So that's forward and backwards, or clockwise, counterclockwise, whatever. So that's how you do that. So that's most of the first one, is going through these things and starting one motor, then maybe starting the next motor, then waiting, and so it's a collection of those things. So it's pretty straightforward. What you would do before you run it, click on Robot and click Compile Program. What that does, oh, it runs it. It didn't like it. Okay, what did I do wrong here? Errors. I've got a, oh, I don't know. That's something else. That's something it did. What did it say? I'm not sure. I'll have to look in that. That was because I did the one with the POE. Quad. I think that's just quad. And it's missing something. Must end with, yeah, so there's some things missing here. I'm not sure what's going on. But down here, everything's okay. In fact, let me pause this. Okay, I fixed it. What it was in my inputs and outputs. What had happened was, let me just show you. Under my quad, this had no sensor. It had the name, but there was nothing there. And so that was my problem. Once I clicked on this and did that, now when I run my compile program, so if you all, it's just an example. It shows you if there's anything wrong with your program before you download it. Always do a compile program before you do compile and download. That sends it to the actual test bed. Always do this first and look for something. If, for example, if I leave that off and I compile, it says errors. Down here it says undefined variable left modo. And so because I had a typo, when I put the R in there, then it will go away. If I take off one of these things are critical. Watch what happens here. Compile program. It says expected a semicolon, found await. In other words, it just kept going. It thinks this is it. It didn't find any signal that said it's the end of that line of code. So this has to be there. That's why the drag and drop is much better than typing this stuff in individually. And it's the easier way to go. So now if I compile, you can see everything is good. You can also, instead of red ones, you can get yellow ones, which means it shouldn't, we think this is what it should be. I can't think of an example. You'll see some yellow ones, and it'll suggest, always look down here whenever you see an X and try to figure out, it'll actually even give you, it'll give you the, if I call that, and I'm not sure what this will say, all kinds of stuff here. Undefined procedure, calling procedure, too many, it does all this, but it'll tell you line 34, so, and it'll have it up here. So it's really easy to fix everything. So that's how you, the initially debug your program. You'll have some where there'll be a whole column of X's here, and a lot of times it's just a missing semicolon somehow, all in between here. And so you do that first before you download it. So that's pretty much the first one. To do the second one, which is about, let me delete this, which is about the inputs, that's where you use the until commands. These are how we do switches. And in fact, if I, and there's also, just like in Word and stuff, there's a undo and a redo. So I can put that up because actually I wanted that there. Because now what I'm going to do, I start my motor, let's say I start my motor, but it's not that I want to wait 5 seconds. I want to stop when I push a button. If I want to do it when I push a button, okay, do not use this one. This command, you'll see it says there until LCD is pressed, a button on the LCD. We don't have the LCD. Do not use until button. You can either use until bump or until touch, okay? And if you can read these, it says, does it until the touch sensor is pressed in. This one, it's till it's pressed in and released. So the bump switch, I push the button and then I let go. This one, as soon as I push the button. So there's different things for different ones. So I'm going to put a until bump and put that in here. Now, I need to say sensor port, and that was, I believe, my bump. I start typing it in. And delay time, actually I believe you can delete it. Let's see if that lets me go with that. And then I compile program. Yep. So that's a different thing. It's the delay between when you release it. Sometimes you need it, but for most not. So what happens now, the motor starts and will keep running forever until you press and release the bump switch, and then it will stop. So now you're starting to control. Now this is we're going to talk about open loops versus closed loop. This is a closed loop, meaning it will stop when that's pushed immediately. The timer is an open loop, and we'll talk about that, what that all means. But basically, you're doing this with everything. So you have, all of these things are until. So you're just going to change this thing here. You're going to change it until the potentiometer has been turned, or until your hand is with less than 12 inches above the sonar, or until your hand is until the light of it, and it's all in there. So that's basically very straightforward. You're just using all of these until commands here. Instead of having the wait, which is a defined time, you're doing an until. So it's doing something until some sensor tells it to do something else. It might be that instead of a stop motor, maybe I want it to now I might want to go left motor, and instead of going back, so now it's going to change direction. Now, if I ran this, what would happen? This would not happen, because you either need, again, you would find you either need a wait or you need an until here. Otherwise, this is going to go, it's going to run, I hit the switch, here, boom, out of my program. So those are the basics. This should get you through those next two sections, the outputs and the inputs.